In the last video lecture, we had learned how to derive the centroids for certain shapes. So here I have just summarized that in a table. You may note it down. For a rectangle, when we take the reference point as this point O, then the centroid will lie at a distance of b by 2 in the x direction. If b is the width and h is the height, then it will lie at b by 2, and along y direction it will lie at h by 2. Now wherever the centroid lies, we can draw an axis. So for example, if it lies at b by 2, at b by 2 we can draw an axis. Similarly at h by 2 we can draw an axis. The axis that is drawn from the centroid is called as centroidal axis. Okay. Next, in the right angle triangle, the centroid, if b is the width and h is the height, then the centroid will lie along the x direction at a distance of b by 3 from point O. So I can draw an axis at a distance of b by 3, and similarly along the height it will lie at a distance of h by 3. Okay, so this is h by 3 and this much distance is b by 3 from point O. In a symmetric triangle, the centroid will lie at b by 2 because it will always lie on the axis of symmetry. So at b by 2 again we can draw an axis. This would be the centroidal axis, and along the height it will lie at a distance of h by 3. So this would be the centroidal axis at a distance of h by 3, and the where these two centroidal axes meet, that is the centroid point itself. Apart from these shapes, we also learned about semicircle. So for a semicircle having a radius of r, along the x-axis the centroid is at a distance of r from this point O, and along the y-axis the centroid is at a distance of 4r upon 3 pi. So 4r upon 3 pi, and the intersection of these two centroidal axes is your centroid. Similarly, for a quadricycle, the centroid lies on a line having an angle of 45 degrees. So it is like 4r upon 3 pi from point O along x, and against 4r upon 3 pi from point O along y. So this is your centroid. These results need to be memorized because we will be using them for solving centroids of certain shapes, certain complex shapes. Now let us see what is the procedure of solving numericals for finding the centroid. Let us say that we have this shape and these are the dimensions 2 cm 6 2. Okay, now the basic let's say that this shape is symmetrical about the vertical axis, so definitely we can find the centroid along the centroid will lie on this axis of symmetry. So we can directly say that x bar is 6 by 2, which is 3 centimeter. Okay, fine. This is one of a kind of problem where it is a symmetrical problem, so we can directly find the centroid along x direction. But now here along the y direction, again along the y direction also it is symmetrical, so we can directly say that it would be 2 plus 6 is 8, 8 plus 2 is 10, so 10 by 2 is 5, right? So in this problem we could find it, but let us say that I want to find using this formula, our centroidal formula. So this is a basic framework of that formula: a into y bar is equal to integration of y dA. Now this integration and all, it becomes complicated for complex shapes. We need to simplify this formula itself. This integration means integration can also be written as summation of individual areas multiplied by their centroids. I will write it as ai into yi. Okay, see, this y denotes the centroidal distance of this elemental area, and this dA is the individual elemental area. We can write this as summation of ai, means I denotes the number of areas that we divide into. So this is the procedure. I'll write the steps for the procedure. The first step is always to set the reference point. So O is the reference point about which I'm going to find my centroid. Then we need to divide the shapes into simple shapes. Now this is a I section. We can divide it into certain simple shapes. For example, this is a rectangle. It's a simple shape. When I mean simple shape, we have rectangle, we have a triangle, we have a semicircle, and we have a quarter circle. Okay, so a rectangle, triangle, a semicircle, and a quarter circle we will call them as simple shapes. Okay, so we will always try to see that whether we can divide a certain complex shape into a simple shape. Here we can divide it into three parts basically. First rectangle, second rectangle, and a third rectangle. So what we did, we first set the reference point, then we divided the shape into simple shapes, and then we numbered those shapes. Okay, coming to this formula now, let us simplify this formula. What we can do is a into y bar is equal to, as I told you, this integration can be written as summation of ai yi, summation of ai yi, where I denotes the number of this shape. Okay, so it is a1. Before this first shape, it will be a1 into y1. So it is a1 into y1. A1 is the area of this first shape, which will be 6 into 2, and y1 is the centroidal distance of A1 from point O. Now since I am finding the y centroidal distance, so this y1 will be the centroidal distance of this A1 along y direction from point O, which is equal to 2 by 2, because for rectangle we know it is h by 2. So it is here, it will be 2 by 2, which is 1 centimeter. Then the next shape is this rectangle, right? So plus a2 by 2, you see there is a summation sign here, so we have to keep on adding how many areas we have divided it into. So it is a2 into y2. A2 is this much area, this area is a2, and y2 will be from point O. See, it is 2, this much is 2, right? 2 plus 6 by 2, because the centroid of this A2 will lie somewhere here, right? So it is 2 plus 6 by 2, that gives you your y2. Then for third shape, it will be a3 into y3. So this is a3, which is 2 into 6, and y3 is the centroid along y direction of this area 3 from point O. So it is 2 plus 6, which is 8 centimeter. 8 plus half of this means h by 2, so 2 by 2, it will lie somewhere here. 8 plus 2 by 2 is your y3, which is 9 centimeter, right? So this entire term denotes this thing, integration of y dA, or we also would call it as summation of ai yi. And this term a is the total area of your entire object. Okay, this a is the total area of entire object. So what we can write it as, this a, if I bring it down, I can write this a as summation of ai, right? The total area will be summation of individual areas, right? So we have now modified this formula into this formula. Y bar is equal to summation of ai into yi upon summation ai. Similarly, for x bar it will be summation of ai xi upon summation ai. This will be the formula for x bar. Now these are the formulas that we will be using for finding the centroid. See, the basic formula remains the same. This is the basic formula. We cannot neglect this formula. This formula will be definitely used when there are certain complex shapes which cannot be divided into simple areas. So in that case, we do have to use this integration formula. But for certain cases where it is easier to divide it into small parts, we can use it into simple parts. We can use these simplified formulas of centroid. Okay, as we solve it, we will see there are few more things that we need to take care of. Let us find the centroid of this area. So what we can see here is we have, first of all, whenever you are given to find area to find the centroid, then you have to check that in what simple shapes we can divide it. Okay, so now you can see that there is a triangle here, then there is the semicircle which is cut out. So whenever you see a shape which is cut out from the area, that shape is considered to be a negative shape. Okay, whenever you see a shape which is cut out from an area, that shape is considered to be a negative shape. And from which area is this cut out? This semicircle we have cut from this rectangle. Okay, there was a rectangle here. From this entire rectangle I cut that semicircle. Yeah, so this would be the correct rectangle shape. From this entire rectangle I cut this semicircle. Okay, so whichever area you are going to consider, you have to take it as positive. Whichever area you are removing, you have to take it as negative. Alright, so in how many shapes can we divide this area? In this total object, in how many shapes we can divide it? In one shape. First is this entire rectangle that I told you, the entire rectangle. This would be one shape. Second shape is this entire triangle, and the third shape will be this semicircle which we have to remove from our rectangle. Okay, so which are the additive areas? Additive means which are going to be positive areas. This rectangle is going to be positive, the triangle is going to be positive, the semicircle is going to be negative. Alright, now let us fix our reference point. The reference point I am going to take is this point here, this point O itself. From this point O I will find my centroid. Now I will be it is a better representation if we do it in table. It is a better form of representation. So figure 1 is your rectangle. The first table, the first column says that it is area. So what is the area of this rectangle? The area of this rectangle will be base into height, which is 100 plus 100 is the base, which is 200. 200 into how much is this? Now see, this semicircle has a diameter of 100, right? It means that this much part is 50. If this much part is 50, then the top will also be 50 because the total is 100, right? So the area of the rectangle is 200 into 50, right, which is 10 raised to 4. Xi is the centroid of this area 1 from point O. So from this point O, what is the centroidal distance of area 1? Area 1 is a rectangle. So the centroidal distance of a rectangle is b by 2 along x and h by 2 along y. So b by 2 means 200 by 2, which is 100. Yes, and yi is the centroidal distance of area 1 in the y direction, which is h by 2 from point O, which means 50 by 2, which is 25. The third table, it is AIXI, which is you have to multiply your area with xi. So 10 raised to 4 into 100 will give you 10 raised to 6. It is AIXI. And the last one is AIYI. It is multiplying your area with this yi. It will give you 10 raised to 4 into 25, which is 250 into 10 raised to 3. Now how I have decided these rows? See, our x bar is nothing but summation of AIYI upon summation of AIXI upon summation of AI. So what all things I need to get this entire thing? I need my AI in summation of AI, so every individual area I need, therefore this first column. Then I need this xi because I have to multiply this xi with ai so that I get ai xi, right? Then that's it, right? And then at the end we'll be taking the summations of all of them, so we'll automatically be getting summation of ai xi and summation of ai. The second shape is this triangle, which is half into base into height is the area. So base is 200, height is 50. So half into 200 into 50. Again, see, it is positive because these are additive areas. First and second area is additive. It's xi. Now the centroid of a triangle from this point O. This is what we want. Okay. The centroid of a right angle triangle is, if this is B and this is H, from this point it is B by 3 from this point, and from here it is H by 3, right? But now you see our point O for this triangle is at this point, and what we want our centroid from point O. So the centroidal distance from point O is now 2b by 3, because from this point we want, right? And what we know, this b by 3 is from the other end, from the right angled end. So here we are not showing from the right angled end, but this point O is at the corner end or at the short end, this point end, right? So from there it is 2b by 3. 2b by 3 means 2 into 200 by 3, which is 400 by 3. And then vertically from point O, right? Now vertically it has a centroid at h by 3. H is 50, so it is 50 by 3, right? But from point O, what is the distance? From point O it is 50 mm plus 50 by 3. Okay, so it is 50 plus 50 by 3, right? That is the distance of the centroid from point O. Next, we just have to multiply our area with xi. We'll get this quantity. Then ai into yi, we'll get this quantity, which is 5000 into 50 plus 50 by 3. The third area is your semicircle. This semicircle is a negative area, so we have to remove that area. So it will be negative pi r square by 2, because that is the area of the semicircle, pi r square by 2. R is 50 mm. See, this 100 is the diameter, so r is 50. Xi. Now the xi of for a semicircle from this point, the centroid is at a distance of r, and in the y direction it is at a distance of 4r upon 3 pi. So the centroid of this semicircle is here along this line, right? So it will be somewhere here like this. But from point O it is 100 plus 50, so it's 150, and yi is from point O, it is 4r upon 3 pi, 4 into 5 upon 3 pi. We get ai as a negative area, a negative term, and ai yi as a negative term. Ai xi we get negative, and ai yi we get negative. Now the only thing left is, for this formula, x bar is equal to summation of ai xi upon summation ai. All of them are summation, so I have to take the summation of area. This will be summation ai. Then summation ai xi means you have to take the summation of this column, and then summation ai yi is this column. Okay, now we just have to substitute in this formula, that's it. So x bar is this summation ai xi upon summation ai, which will give you x bar is 97.31935 mm and y bar is summation ai yi upon summation ai, which is 45.1548 mm. So our centroid, just a minute, so our centroid lies somewhere, it's 97 from point O, right? So the centroidal axis will be this and 45 along y direction, so somewhere around this. So this is the possible location of our centroid. Okay, let us move on to the next numerical. We have this shape which is having a 10 cent. So you know there are a lot of shapes which are negative here. First we have to understand what are the simple shapes that we can get from this. So the simple shape, the most simplest shape that you can get is, you can make it as a rectangle. Okay, this is a rectangle that is getting formed like this entire rectangle. Now this rectangle will be additive because the entire rectangle will be positive. Now from this rectangle, what all areas we have to remove to get this shape finally? So we have to remove this quarter circle, we have to remove this semicircle, we have to remove this triangle. Then we will get the desired shape, right? So you have to think that what are the individual simple shapes that you can form for a particular area and what shapes you can remove from a certain area. So this rectangle, I will call it as first area. Then this triangle which I have to remove, which is a subtractive area, I will call it as second. Then the quarter circle, which is again subtractive, I will call it as third, and the semicircle, I will call it as fourth. So the first shape is this entire rectangle, which is a additive area, which is a positive area. So the area of this rectangle will be base into height, which is base is 3 plus 10, which is 13, and height is 10, so it is 10 into 13, which is 130. Xi is, I'll be setting my reference point at the bottom left corner of this rectangle, this point. From this point I'll be finding my centroid. So from this point, the centroid of the rectangle along x direction is 13 by 2, base by 2, and along y direction it is height by 2, which is 10 by 2, 5 centimeters. So ai into xi is 130 into 6.5 and ai into y is 130 into 5. Second area is this right angle triangle, which is a negative area. We have to subtract it. So it's minus half into base into height, 3 into 6, minus half into 3 into 6, and then xi is again from point 2, it is base by 3. So it's 3 by 3 from point 2, and along y direction it's h by 3, so it's 6 by 3. ai xi is minus 9 into 1 and ai yi is minus 9 into 2. Then the third one is this quarter circle. Now the quarter circle is again a subtractive area, so it's minus, and the radius of this quarter circle is 4 centimeters, so it's minus pi r square by 4. xi for this quarter circle. Now we have seen our quarter circle like this. From this point, that is this point here is this point, right? So it is at a distance of 4r upon 3 pi. 4r upon 3 pi in both the sides, x and y, right? So xi from this point is 4r upon 3 pi, 4 into 4 upon 3 pi. Yi is 6, and then you see that the centroid for this shape will lie here. Okay, it is 4r upon 3 pi and 4r upon 3 pi like this. This is your centroidal distance from this point, right? But we want from point O, so it is 6 plus 4 minus 4r upon 3 pi. Okay, it is 6 centimeter from point O to we reach here, then we add 4, then we reach at this point, then from 4 we 6 plus 4, 10, from 10 we subtract 4r upon 3 pi, we reach this point, the point of the centroid. So it's 6 plus 4 minus 4r upon 3 pi. AIXI is minus 21.337 and AIYI is minus 104.323. Then coming to the fourth shape, which is your semicircle. So for the semicircular shape, the area is again, it's a subtractive area, it's minus pi into r is 5, so pi r square by 2 minus pi r square by 2, it's minus 39.27 xi. Now this semicircle, see, we have seen semicircle like this, okay, and here is the centroidal axis, one centroidal axis, second is this centroidal axis, right? This is 4r upon 3 pi and this is r. If I see this semicircle, it is a tilted one, it is rotated to the left, so its centroidal axis, this is the centroidal axis and this is the other centroidal axis, so this much distance is 4r upon 3 pi, right? So x bar we want from this point O, so it will be this 3 plus 10. When we add this 3 plus 10, we reach at this point, this line, then we subtract 4r upon 3 pi, we reach to this axis. So that is the axis that we want, that is the centroidal point axis, right? So it is 13 minus 4r upon 3 pi and yi is from point O, it is directly 10 by 2, which is 5. So AIXI and AIYI we get, then we add all our areas, we will get summation AI, and then we add all the summation AIXI and summation AIYI. So now it's pretty much simple. X bar is summation AIXI upon summation AI, which is 5.6024 and y bar will be 4.79031. So if we try to plot it, it will be 5.6, right? So it has to be somewhere around here. This would be one of the axes, and 4.79, so this somewhere here would be the axis. So this is the centroid G, which is at 5.6024 comma 4.79031, right? We'll solve one more numerical. So we have a lot of shapes here. Let us see how we can simplify this. What we can do is we can take a shape, this entire thing, okay, like let me use some other pen. So this, and till this point, this entire thing we can take it as a rectangle, and from this rectangle we will keep on removing. So what all things we are removing? We are removing first of all this right angle triangle we are removing, then we are removing a rectangle, another rectangle we are removing, and then we are removing this semicircle, okay. So this entire area I will give it as the first number, this rectangle area I will give it as the first number. Okay, apart from that, now we understood that this is a additive area, this entire rectangle, and the right angle triangle, this rectangle and this semicircle are subtractive areas. What about the top part? In the top part, what we can do, we can take a rectangle, entire rectangle like this, and from this we can subtract this area. Okay, and then this will be another quarter circle that we need to add. So in total we have 7 areas. See, this is the first area, the total entire rectangle. Then this is the second. We use another pen for this. This is the second area, the third area, fourth area, the total rectangle. This is fifth area, sixth area, and seventh area. Okay, so in total we have 7 areas. First rectangle is 48. You see that this is 16, 20, and this is 24, so it becomes 40, and 40 plus 8 is 48 is the base of this rectangle, and the height is 12 plus 8, 20, so it's 960. Xi from this point, I'll take this as reference point, it's 48 by 2, 24, and Yi is 20 by 2, 10. So AI Xi and AI Yi we can get. Then we have this right angle triangle, which is a subtractive area, negative area, so it's half into base is 16, height is 8, so it's minus 64, and Xi from point O. Now this is a right angle triangle like this, right? We know that the centroidal distance from the right angled point, which is base by 3. From the other end it is 2b by 3, right? So here it is 2 into 16 by 3. Yi will be 8 by 3, because this is the simple h by 3 it is from point O. So AIXI and AIYI we get. The third area is again a subtractive area. It's this rectangle, which is 24 into 8, so it's minus 24. 24 is the width and 8 is the height. Xi for that rectangle is, it will be 16 plus base by 2, which is 24 by 2. So 16 plus 12, and Yi from point O will be just 8 by 2, which is 4. The fourth area is the semicircle. Again it's a negative area, so we have minus pi r square by 2. The diameter is 24, so the radius will be 12, so it's minus pi r square by 2. Xi will be 16 plus 24 by 2, so it's again 16 plus 12. Yi will be 8 plus 4r upon 3 pi. See, the centroid of this semicircle will lie somewhere here at this distance, so this is the distance that we require. This is the y bar or yi for this semicircle, so it is 8 plus this much is 4r upon 3 pi. Right? Then we have the fifth area, which is this complete rectangle. It's a positive area and the width is 16 plus 24, which is 40, and the height is 8, so it's 40 into 8. Xi is from point to it is 40 by 2. From this point it's directly half base by 2, which is 20. Yi will be it's 20 plus 8 by 2, because it will lie at the h by 2, right, h, which is 8 by 2, so 20 plus 8 by 2 is your yi, which is 20 plus 4, so you get some AIXI and AIYI. Then we have this area 6, which we are removing, so it is subtractive. Minus 8 into 8 is minus 64. Xi is 8 plus 8 by 4, so it's 8 plus 8 by 2, so it's 8 plus 4, and yi is 20 plus 8 by 2, which is 20 plus 4. So we get ai xi and ai yi, and the last area here, which is your quarter circle, so it's pi by 4 into 8 square, and pi r square by 4, 8 is the radius. It's again an additive area because we are adding it. Now the xi, that is its center from point O, will be at 4r. I mean this much is 40, so 40 plus 4r upon 3 pi, and in the y direction it will be 20 plus 4r upon 3 pi. This much is 20, so 20 plus 4r upon 3 pi. Now we just have to take the summation of all areas, summation ai xi and summation ai yi. We can find now x bar and y bar. So x bar is summation ai xi upon summation ai, which is 23.5453 mm, and y bar is summation ai yi upon summation ai, which is 16.6066 mm. Let us try to plot it on the shape. So it's 23 in the x direction, right? So this much is 16, and somewhere here, this is one of the locations, and along the y-axis it is at 16.60. so this much is 8. Okay, so it's somewhere this point. So you see now the centroid is actually not in the area, but it is actually outside the area. Means it is not covering the actual part of the area. It's not lying on the actual part of the area. So this is one of the very important points about centroid, that it can also lie outside the area. It need not be necessarily inside the area. Okay, there are multiple examples where the centroids lie outside the area, and there are there are illustrations on Google as well. You can just Google it, and you will see that there are two forks. Your eating forks are there, right? When they are intertwined with each other, you can fix a toothpick in between them, and then you can balance those two forks on the toothpick. So this you can see in the Google. I'll leave that upon you. So this was it for today's lecture. Till then, take care. Thank you.